Students, let us start another very important topic of class 6th, fractions. Fraction is a part of a whole. The whole here can be an object or group of objects, but all the parts of the whole must be equal. Look at this figure here. The first one is whole. It's a complete circle. In the second circle, if we divide the circle into two equal parts, then the shaded portion is half. That is half of the circle. In the third circle, if we divide circle into four equal parts and shade only one part, then the shaded part is 1/4 of the circle. In the fourth circle, if we divide the circle into four equal parts and shade three of its parts, then the shaded part is 3/4 of a whole circle. I'll give some more example for fraction. 3 by 11 means 3 out of 11 parts. Here 3 represents numerator, 11 represents the denominator. So in a fraction, there will be numerator as well as denominator. We have different types of fractions like proper fraction, improper fraction, and mixed fraction. Let's see each one of them one by one. Let us take up proper fraction. What is proper fraction? A proper fraction is a fraction which is less than 1, or where the numerator is less than the denominator. Here the denominator shows the part of whole has been divided, and the numerator shows the part which has been considered. What is improper fraction? Improper fraction is a fraction which is greater than 1, or where the numerator is greater than the denominator. Let's understand this with an example. Suresh has 5 chocolates and he has to divide those chocolates among his 4 friends. We can divide each chocolate into 4 parts, and each one will have 1/4 part of each chocolate. So each friend will be having 5 parts of 1/4 part. Now 4 parts make one whole. So basically each one of them is getting one whole and a part, and it is written as 5/4. If we have 4/5, it becomes a proper fraction. 5/4 is an improper fraction. Next we have mixed fraction. What is a mixed fraction? Mixed fraction is a combination of a whole number and a proper fraction. Let the example of improper fraction only. The division can made in another way. We can give one chocolate of them, each one of them. We can give one chocolate to each one of them and divide the 5th chocolate into 4 pieces. So each one will be getting one full chocolate and 1/4 of the last chocolate. and it can be written as 1 added to 1/4, nothing but 1/4. This is mixed fraction, the combination of a whole number and a proper fraction. If you observe it carefully, 5 upon 4 is improper fraction, 1 by 4 is a mixed fraction. Both are one and the same. How do we convert a mixed fraction to improper? Here we have some steps for converting mixed fraction to improper fraction. Obtain the mixed fraction. Let the mixed fraction be 5 2 by 6. You must observe how I am reading it. 5 2 by 6. It is also read as 5 integer 2 by 6. Second step, identify the whole number, the numerator and the denominator of the proper fraction. Whole number is 5, numerator is 2, denominator is 6. Apply the formula. Whole number multiplied to the denominator added to the numerator upon denominator will give us improper fraction. Here 5 is multiplied to 6 and then added to 2 divided by 6 will give us 30 plus 2 divided by 6, nothing but 32 upon 6. So this 32 upon 6 is a improper fraction. 5 2 by 6 is a mixed fraction. Let's see one more example. 1 by 3. Let's apply the formula. 1 is a whole number, it's multiplied to the denominator added to the numerator upon 3. So we get 4 upon 3 as an improper fraction. Now we learn the reverse part. If a improper fraction is given, how do we convert to mixed fraction? Follow these steps. Obtain the improper fraction, then divide the numerator by the denominator and obtain the quotient and the remainder. Quotient is written first. Along with that, remainder by denominator will give us mixed fraction. Let's see with an example. If we have 11 upon 3, when 11 is divided by 3 times is 9 and we get the remainder 2. So the quotient is written. Along with the quotient, the remainder divided by the denominator is written. This particular thing is a mixed fraction of 11 by 3. Next we have a concept called as a representation of fraction on a number line. How do we represent a fraction on a number line? We can show fractions on the number line. In order to represent 1 by 2 on the number line, we draw a number line and look for the portion between 0 and 1. Because the value of 1 by 2 is 0.5, it's larger than 0 and less than 1. 0 is less than 1 by 2, less than 1. So this number is between 0 and 1. Now we divide the gap between 0 and 1 into two equal parts. The point of division will represent 1 by 2. Look at this. 0 and 1 is made into two equal parts, and this point which is making into two equal parts will represent 1 by 2. Same way, to represent 1 by 4 on the number line, we divide the gap between 0 and 1 into 4 equal parts. The first part will represent 1 by 4, second part 2 by 4, the third part 3 by 4, and the fourth part is 1. Here, between 0 and 1, it has been divided into 4 parts. First part, second part, third part, fourth part. The first point here represents 1 upon 4. The second point will represent 1 by 2 and the third part will represent 3 upon 4. Now we will learn the simplest form of fraction. If the numerator and the denominator of a fraction have no common factor except 1, then it is said to be the simplest form. It is also called as lowest form. For example, 1 by 2, 1 by 3, 2 by 3, these are all simplest form. If you take 2 by 4, is not a simplest form. The simplest form of 2 by 4 is 1 upon 2 is simplest form. Let us learn another concept called as equivalent fraction. Equivalent fractions are the fractions that have the same value in the simplest form. So for example, look at this: 1 by 2, 2 upon 4, 3 upon 6, 4 upon 8. These are all equal to 1 by 2. On simplification, we get 1 by 2 only. Observe here how many parts have been shaded here. Only one part out of 2 parts are shaded. If you look at one square here, one square is having 2 different colors, one white and one orange. Same way, if you observe, half of the square is colored, half of that is not colored. In all these figures, half of the square is being colored, so they all represents 1 by 2. 1 by 2 part is colored and 1 by 2 part is uncolored. These fractions 1 by 2, 2 by 4, 3 by 6, 4 by 8, they are all equivalent. Another example I'll give you: 2 by 6, 1 by 3, 6 by 18. These are also equivalent fractions because they all will be equal to 1 upon 3 on simplification. The equivalent fraction of a given fraction is obtained by multiplying both numerator and the denominator by the given fraction by the same number. Suppose if I have, say, 2 by 3, I can get equivalent fraction of 2 by 3 just by multiplying 3 to both numerator and denominator, 5 to both numerator and denominator, 7 to both numerator and denominator. In general, some number is multiplied to both the numerator and the denominator. We get equivalent fraction. Next, we have a beautiful concept called as a like fraction and unlike fraction. Observe it very carefully. Like fractions and unlike fractions. Fractions with the same denominator are called like fractions. For example, 1 upon 3, 2 upon 3 are like fractions. 1 upon 4, 3 upon 4, they are like fractions. The fractions with different denominators are called as unlike fractions. For example, 1 by 3, 2 by 3 are unlike. I want you to identify which one of these are like fractions and unlike fractions. 2 upon 3 and 4 upon 3, it is like fractions. 2 by 5, 1 by 3, it's unlike. 11 upon 5 and 17 upon 4 is unlike. And 2 by 5, 9 by 5, they are alike. Next, we have comparison of fractions. We often come across a situation where we need to compare the fractions. There is a systematic procedure available for comparison of fractions. It is divided into comparing like fractions, which is easier way, and the other one is comparing unlike fractions. Let's take a deep dive into it. Let me consider comparing like fractions. Look at the numerator values. The numerator values only will decide which fraction is larger. If I have 5 by 6 and 2 by 6, it is larger than 5 by 6 is larger than 2 by 6 because 5 in the numerator is larger than 2 in the numerator. 3 by 6 is larger than 0. The reason is 3 by 6 is larger than 0 by 6. 0 is same as 0 by 6. Look at only the numerator, 3 greater than 0. Therefore, 3 by 6 larger than 0 by 6. Same way, we have 1 by 6 less than 6 by 6. 8 by 6 larger than 5 by 6. So we can write 1 by 10 less than 2 by 10 less than 3 by 10 less than 4 by 10. We are looking at only the numerator value. Look at how to compare unlike fractions. We can further divide it into two parts. First part is comparing the fraction with the same numerator. For example, 2 by 5, 2 by 7, their numerators are same. If the numerators are same, the fractions with the lowest denominator will be the greater value. I'll make it very simple by this example. If you consider 2 by 10, 2 by 100, look at the value of 2 by 10, it is 0.2. 2 by 100 is 0.02. Which one is larger? 2 by 10 is larger. The denominator with the smallest value will be the larger. So, in 2 by 5, 2 by 7, 5 is less than 7. Therefore, 2 by 5 is greater than 2 by 7. Let's look at how to compare if they have got different numerator and the different denominator. Here we would be using a technique of equivalent fraction. We would have to convert each fraction into equivalent fraction such that they become like fraction. We have to convert them into like fractions by the use of equivalent fraction. Then we go for comparison. So what we do is we will first find the LCM of the denominator, then we convert equivalent fractions such that the denominator is the LCM. Then as we were comparing the like fractions, we compare it in a easier way. Let us understand with this example here how to compare 2 by 3 with 5 by 7. Just observe the numerator and denominator, they are different. In such cases, we would take LCM. LCM is 21. We make the denominators of both these numbers as 21. If you multiply 7 to both numerator and denominator of first fraction, we get 14 by 21. If you multiply and divide by 3 for the second fraction, we get 15 by 21. Clearly 15 by 21 is larger than 14 by 21. So 5 by 7 is larger than 2 by 3. Let us take up another example. to understand it in better way, 5 by 6, 13 by 15, they have different numerator and denominator. The LCM of the denominators 6 and 15 is 30. So we convert by multiplying 5 and 2 to both numerator and denominator of both fractions respectively. We get 26 upon 30, which is larger than 25 upon 30. Therefore, 13 by 15 is larger than 5 by 6. Let's see how to add the fraction. To add the fraction, we often come across a situation where we need to add two fractions. There's a systematic procedure for adding the fractions. It is divided into again two parts, adding like fractions and adding unlike fractions. Let's go deep into it. Adding like fractions, for example, 1 by 5 is added, we get 2 by 5. 1 by 6, 4 by 6 is added, we get 5 by 6. What do you observe? We add only the numerators. If the fractions are like fractions, it's very easy to add. We add only the numerators, keeping the same denominator. Adding unlike fraction is little different. First, we need to convert unlike fractions into fractions using like fractions by using the LCM of the denominators and convert each one of them using the same LCM. And then we add like a like fraction. Let's take up example 1 by 2, 1 by 3. If you want to add, take LCM. LCM is 6. Convert each one of them with the same LCM as the denominator. Then we add 3 to 2 by keeping the same denominator 6. Let's see how to subtract. Again, we have the same procedure. If they are like fraction, it's easy to subtract. If they are unlike, first we will make them as like fraction and then subtract. As we were doing addition, same subtraction is done. This is how we subtract. Let's do a comparison, addition and subtraction of mixed fraction. Two mixed fraction can be added or subtracted by adding and subtracting the whole numbers of the first two fractions and then by adding or subtracting the fractional part together. If two mixed fractions are there, they can be converted into improper fraction and then we can follow addition and subtraction. If we have 1/2 to 1 by 3 to be added, we can add it like this. 1 is added to 2, then 1 by 2, 1 by 3, they are added together. And we get the result as 3 by 3, 5 by 6. Let's add 1 by 2 to 1 by 3 just by taking LCM. Look at how it's been done. First, this mixed fraction is converted into improper fraction. Then LCM is taken. The denominators of both the fractions are made as LCM. Then addition is done. Same is followed for subtraction also. With this, I'll end today's session. In the next session, we will go through the questions of exercise to understand the concepts clearly. That's all for today's session. Thank you.